Professor Charles Karl received this year's Nobel Prize in Physics for his groundbreaking achievements concerning the transmission of light in fibers for optical communication. What is an optical fiber and why is it important to us?
An optical fiber is a hair-thin wire made of silica glass. It consists of a core surrounded by cladding. The refractive index of the core is slightly higher than that of the cladding, so that light can be trapped in the core and travel along the fiber by the principle of total internal reflection.
For an optical fiber to be useful as a transmission medium for communication, it must be very transparent. Professor Karl pointed to the direction of making such a fiber in a seminal article published in 1966. Nowadays, the loss of an optical fiber is only about 0.2 dB per kilometer at the near-infrared wavelength 1.55 micron. To put it in simple language, light loses only half of its brightness after passing through a 15 km thick window made of the same glass.
The information transmitted through an optical fiber is in the form of short optical pulses. For example, a telephone channel requires a transmission rate of 64,000 pulses per second. A carefully designed optical fiber link can transmit more than 10 billion pulses per second, or an equivalent of 150,000 telephone channels simultaneously over a distance of thousands of kilometers. We can actually do much better. We can generate high-rate pulses from sources emitting at different wavelengths and feed them all into the same fiber. In this way, we can multiply the capacity of an optical fiber by many more times. This technology is called wavelength division multiplexing, or WDM in short. Now here I would like to demonstrate the idea of WDM with a simple experiment. I'm going to feed two wavelength channels into the same fiber. Now this is the sending end of the fiber. As you can see, there are two light sources, one is red and the other is blue. And they are modulated by two pieces of music and transmitted through the same fiber. Now this is the receiving end of the fiber, and we have a receiver which records the two pieces of music together. Now, I use the red filter to select the red channel to retrieve one of the pieces. Now, I use the blue filter to select the blue channel to recover the other pieces of music. Nowadays, using the WDM technology, a submarine fiber cable like this can transmit millions of telephone channels or an equivalent amount of data simultaneously across Pacific Ocean.
Literally, the continents of the Earth are physically connected by optical fibers. Optical fibers have already reached the doors of our homes, and one day they will be brought into our homes.
Scientists and engineers are still working hard to further increase the capacity of optical fiber to meet the growing demand for low-cost, high-speed transmission. In these laboratories, we are doing research on various kinds of fiber optic components and devices to facilitate the transmission of light for different applications. Optical fiber network is the backbone of the information technology and will remain so in the foreseeable future.